Okay, so we're continuing on with the Arithmetic Series. So this is the second part of your assignment. We did the sequences first. So let's jump into it. These are the two formulas that you would use for actually totaling or summing an arithmetic sequence. So these are actually series. It's written as sequence here, but it's an actual series. Because we're now, it's a common difference between my terms, and now I'm adding them all together instead of just going from term to term. So let's take a look at our first one. Again, it's still the same terminology as the arithmetic sequences. This is still my first term, T1 here. You can see my common difference is 6 here between each one. I could write a general formula if I wanted to. For this one, right, my first term is 5. My common difference is 6. And then I go all the way up to 65 and then stop. Now, there's a couple of things I need for the formula for either one. For this one, I would need the number of terms, the value of the first term, and the value of the last term. Over here, right, I need the common difference, the total number of terms, and the first term. So similar things. So we just have to figure out which one of the two is easier to use. Do I have all the information for one or the other? If not, which one can I easily find all the information for? So I don't have all the information for either one here. I don't know the total number of terms. And so what I would need to know, or the value of the last term. Actually, I do the value of the last term. So what I'm going to do is figure out how many terms do I have here. Right? So in this particular case, right, there's a couple different ways that you can do it. Since this one is fairly straightforward, you could just keep saying how many times do I have to add 6. Right? Or I could say I know that 65 is equal to my first term, T1 plus D on my n minus 1, where I'm solving for n, the total number of terms. 65 is equal to my first term, 5, plus d, my common difference, which is 6, to n minus 1. Now, I'm going to let you do the algebra work yourself. I'll do it really quickly here. Divide both sides by 6, you get 10. 10 is equal to n minus 1, so you get 11 is equal to n. Now I can fill that into this formula right here. So if I fill that in, I'll get that the sum of my 11 terms is equal to my 11 terms onto T1, which is 5, plus my last term, which is 65, all divided by 2. So the sum of my 11 terms here, a little bit of quick math, 70 times 10 would be 700, but I've got 11 of them, so I've got 770. 770 divided by 2 is going to give me, let's see, I get it written down, 770 divided by 2, it's going to give me 385. So there is the total of my 11 terms. Now I'm going to end up erasing that because I need the space to do the next one. All right. So again, my first term is 10. My common difference, how much do I have to add each time? -3. My last term here is -17. So I use the same formula again here. I know my last term, or my Tn, is -17. I know my first term. Fill in the information. First term is 10 plus -3 onto formula again. Although you can use the other formula here, either one will work. So let's use the other formula just so you can see an example of it being used. I'll fill it in exactly as we see it here. So the sum of my 10 terms this time is equal to 10 divided by 2, all onto 2 times my T1, which is 10, plus my common difference of -3 times my number of terms minus 1. Now, some quick mental math here. Okay, this is going to give me 20 plus this will give me -27. So I've got 20 plus -27, so that's a total of -7. And then that's going to be multiplied by 5. So -7 times 5 gives me -35. So there's my total. All right. A little nicer one here. This one just gives you the information. It tells you the value of Tn is 71. The first term is 5. The total number of terms is 7. So you just figure out which formula do you want to use. In this case, there's only one that I would actually want to use because I don't have the D or common difference given to me here. But I do have N, T1, and Tn for this formula. So I can fill it directly into that formula. So I can say the sum of my 7 terms here is equal to number of terms, which is 7 times T1, which is 5, plus my last term, which is 71, all divided by, right up here, 2. So again, a little bit of mental math. Depends on how you want to actually do it. I'll probably do 7 times 5 is 35, plus 7 times 71, 7 times 70 is 490. So 497 here, all divided by 2. So you end up with 532 divided by 2. So that's going to give us 250 plus another 16 is 266. If you find an error in my mental math, it's fine. You can always check yours with the calculator. All right, so now we're going on to sigma notation. And so sigma notation is when you take the general formula for your series and say, I'm going to add up how many terms or which terms. So for instance, these general formulas that I've had back here, so let's say this general formula right here, if I wanted to, I could actually multiply this all out and collect like terms, and I would get 6n plus 1. And that would be the same as what's written right here. So my general formula for the sequence would be 6n plus 1. And that would enable me to find any term that I want. So if you look here, I've got a general formula. It's just not written the way we're used to. 5n plus 1. And what this is saying, this is the sigma, right? And it's saying I want to add the first term through to the fourth term. So, it's saying it wants you to expand that. So, I would take my first term and write that out. So, 5 times 1 plus 1, and then plus 5 times my second term, and then my third term, and then finally my fourth term. And so there's it expanded, and now it wants me to actually evaluate it as well. So let's evaluate it. I've got 5 plus 1, so that'll give me 6, plus 10 plus 1, so that's going to give me 11, plus 15 plus 1, that's 16, plus 20 plus 1, so that's 21. Now, you could use one of the sum formulas. In this particular case, it's a lot easier to just actually mentally add them up. Now, this formula, you could actually arrive at it without too much trouble. I mean, derivation for it. If you look here, if I add my n two terms, 6 and 21, that gives me 27. If I then take the next two terms in, 11 and 16, that's 27 as well. So I've got two 27s to add together, which gives me 54. Oh, you would notice if you had several of these, if you took the first and the last term and added them together, the second term and the second to last term and added them together, third term and the third to last term and added them together, you would always have the exact same total. Okay? So basically what I'm adding is not 4, but 2 of the total of the n2 terms. Half of the total number of terms that I have. So the total number of terms in half times the total of your n2. So there's how you come up with the formula. All right. So this one says write the series in sigma notation. So in order to do that, I need to know the general formula. So my general formula, Tn equals T1 plus D onto n minus 1. So then I get Tn, in this case T1 is 6, plus my common difference, you'll notice, is 7, n minus 1. Now normally we leave it like that, except for when we're going to do sigma notation, we like to reduce it down. And so I get Tn is equal to 6 plus 7 times n, so 7n, 7 times n equals subtract 7. So you get Tn is equal to 7n minus 1. So then to write my sigma notation, I'm going to go from my first term, so I've got n equals 1. This is the general formula, so that's what goes here, 7n minus 1. And then I count out how many terms do I have? 1, 2, 3, 4, 5, 6 terms. So I go from the first term through to the 6th term. And that's it. So that should be enough to finish off the assignment. As I mentioned in the last video, I will save these smartboard notes. So if you want to just watch instead of copying the notes, you can. And also I go quickly, so for all of your videos, I expect you to just pause when you want to catch up with the notes. That's it.